Hello, Mr. Sorrentino here, and I am doing this video for section 2.6 of Math 31, which deals with variation and applications. Um, Variation problems are like one of the first main types of word problems that uh, you're going to be made to work with. Um, and they're pretty much direct translations. They're more straightforward than sometimes other word problems may tend to be. Um, you just have to know what operations, or how to set up the problem based off of the information. Um, Now, as you go through these, there's going to be many different instances of these. I'm only doing three examples to kind of like demonstrate, how to go about doing them, but you're going to find other instances as you go through your textbook. So certainly practice this skill extensively enough so that you can understand what's going on with it. So, a direct variation, usually you're going to see it described as y varies directly as x, or whatever the two variables may be. You might even see it referred to as directly proportional. Same thing. Basically, what that means is as one changes, the other one changes comparatively in the same way. That means both, if one increases, the other increases. They may not increase at the same rate of speed, but one's going to increase, the other one's going to increase as well. Or if one decreases, the other one's going to decrease as well. Um, so the two formulas that we tend to make use of is y equals kx, which is the primary one I make use of. You also have y over x equals k. I would say like get to know one or the other, but don't try to use both a whole lot because that can sometimes cause confusion. I usually look as a direct variation as a multiplication with the constant, and that's how I tend to remember it. And these tend to have linear graphs, which is why that's brought up here. But generally, when you do problems like this, there's two stages. The first stage is you want to do a setup that ultimately will solve for k, your constant of variation. And then the second one is you're going to use the formula you now have from 1 to answer the question. So it's not going to be something you're going to be able to go directly to answering the question automatically. Although some setups you might be able to do that. Um, but generally that's the process we're going to use to solve these. So for instance, in example 1, the score on the last exam varied directly as the number, oh, let's repeat it twice, of hours the student studied. So I'm going to say, okay, like score varied directly with number of hours. That's a very general formula. For this formula to be of any use to me, I got to figure out what k is. So when I have this, when I'm in step 1, I'm going to be given a pair of values for the variables. I'm looking for that. So basically, when I'm in step 1 of the solution process, there should be an S given to me, and there should be an H given to me, letting S stand for score, H stand for hours. Make sure you always know what you define your variables to be. I mean, you can let them be any letters you want, just know what you have standing for what. If you want Y to be the score and X to be the hours, make sure you remember that. So I know I'm going to be looking for that kind of pairing, and then that's going to help me figure out what K is, and then I'll be able to answer the question at the end of step 2, because the question I'm looking to, it's telling me if a student studied 5 hours and had a score of 72, how many hours would a student have to study to score an 85? So basically, we're looking for how many hours to score an 85. So down here, when I start this off, I'm not going to know the number of hours. I know the score I'm looking to achieve is an 85. Well, I'm not going to be able to answer that unless I have this equation up here defined. So for me to figure out what k is, I need to, right now I have an equation with three variables. In order to solve for any one of those variables or letters right now, I need to know what the other two are. And so that's why I need to know an S and I need to know an H, and I'm given that. It's told when a student studied for 5 hours, they had a score of 72. So now my formula is 72 equals K times 5. For me to solve for K, I would divide both sides by 5, and I would get that K is 72 over 5, which is the same thing as 14.4. So that's not my answer. I'm not done with this problem yet. I just now have my constant of variation. So now, when I get to step 2, and let me scroll down a little bit, my formula now is S equals 14.4 times H. Now, with this formula, if I know one of the values of the variable, I'm going to be able to figure out the other. And so now it's telling me, now I can answer the question because I'm looking for the number of hours it takes to get a certain score, and that score is an 85. So I'm going to divide both sides by 14.4, and I get H to equal about 5.90, it goes 027, but 090 hours. So, I could even put this in a full sentence to score 85. The student would have to study 5.9 hours to score that 85. So, and these formulas are is basically the extent of the work you have to do. But you do have to remember there's two different stages. Um, a more direct way is I'd have to use this idea up here and then set up two proportions because it doesn't matter how I set them up. If it's going to be if they're varying directly, I could say that 72 per 5 hours would equal an 85 per how many hours, and go through the same process. Because I would have, doing my cross, but this goes into cross multiplying and things that we haven't discussed extensively yet. And therefore, depending on how you remember, but if you would solve this equation using cross multiplication and such, you could solve it. We're going to talk about cross multiplication a little bit more when we start solving rational equations. We haven't gone through that yet. But if you know how to do that, if you solve this, you'd get the same 5.9 that we got before. So that's the first type of variation you're going to encounter. The second one is an inverse variation. With an inverse variation, you're going to, again, it's going to state outright, you're going to see the words, either varies inversely or is inversely proportional. Those are two words you're looking for. And basically what that means, as one of the variables increases, the other one's going to be decreasing. They may not be going at the same rates. One could be increasing at, $2 per hour, the other one might be decreasing by 50 cents per hour. They're not necessarily the same units or going at the same rates, but they are going in opposite directions. The main formula that I tend to use is this one here. This one you can use if it's the fact that you don't want to do the extra step of finding K. But it's still the same process, so that's the one I'm going to show. Again, I want to do a setup to eventually figure out what K is. Then I'm going to use my formula that I got from the results of 1 to answer the question asked. So, again, it's going to be described as a word problem, and some of them are not going to be like, really like wordy word problems like this. You just might say, or just might just say, assume y varies directly as x. Y is 4 when x is. They just might give it like a small sentences or parts of sentences. That's all fine too. It works the same way. So again, I gotta figure out what's going on with this and interpret what I have. Um, Recognizing here in step 1, I have to have both variables known. And when I'm getting to the question is going to have one known, the other one I'm looking for. I'll say other sought. So let's look and see what information we have and dissect this problem. So we're told that the intensity I, and they're actually giving me a variable here, varies inversely as the square of the distance from the bulb. So it's giving us a formula, but it's kind of a little different here. It is mentioning the square of the distance. And I'm going to let distance be d, so it's telling me that I varies inversely, so it's going to be my constant k divided by the square of the distance. So that is my general formula. In step 1, I'm looking to find k, and hence the formula. Because once I know what k is, I'll have the formula, because I and d are the two variables here. K is assuming to be the constant. So I want to find that formula. So I'm going to be given a situation where I know both pairs. I'm going to know an I, and I'm going to know a D. That information is going to be given to me. And I can see in the second sentence it says if I is 90, W per M squared. I don't even have to really worry about what those stand for. I just have to make sure I know what the units are, so when I get into dealing with it later, I know to put the right units in. And the distance is 5 meters. The question that's being asked, and what I'll be able to answer in that too, how much further would the bulb need to be moved in order to have the intensity be 40? So I know I'm going to need to figure out what D is, but what I'm actually going to be looking for is, how much further I have to go. It's going to be D minus the 5 we had before. Because if it varies inversely, that means that as I decreases, which it is here, I expect the distance d to increase, and therefore I expect d to be a bigger value. And so it wants to know how much further I'm going, but to answer that, I have to know, well, what distance do I need to set this at? That means that they have to be giving me an I, which they do. They give us it's 40. I'm not going to be able to answer that question in 2 until I have a formula that relates I and D together. I mean, I have the formula with K unknown, but I got to figure out what K is. So here I'm going to say, okay, well, now I know that 90 equals K over 5 squared, which of course is 25. So my constant of variation is going to be 90 times 25, which equals 90 times 25 is 2,250. So my formula is I equals 2250 over d squared. That's the formula I'm going to use to now answer the second part of this and finding that distance. Because now what I know is that let's go back to red again. I know that my intensity now is 40. That should be 2,250 divided by d squared. So cross multiplication is something you should kind of still know, but on the same token, if I want to get d alone on one side of the equation, it should also be in the numerator. I'd multiply both sides by d squared. Let me scooch this down a little bit. I would divide both sides by 40. 2,250 divided by 40 is 56.25. I'm going to square root both sides. Since a negative would cause me to have negative distances and negative intensities, I know that doesn't make any sense, so I can exclude the plus or minus symbol here. So I would need to take 56.25 and square root it, and that gives me 7.5 feet. Then I jump to the conclusion, well, since the answer I'm looking for is actually 5 minus that distance, that's 2.5 feet. So that's how much further I have to move the bulb. So to formulate my final answer for this and state it, the bulb would need to be moved 2.5 feet further away for the intensity to now be 40. And again, I think that's watts per meter squared or something of that nature. So, that's how you go about doing these. I mean, and it doesn't matter how complicated they get. They might have several variables being related directly and several others being related inversely to all one another. This means you have to keep track of what's going on here. And that's when we get into combined variations. With combined variations, we're putting direct and inverse variations together. Just as a side note, there's also a joint variation that I want to highlight here. And basically, when it says something varies jointly, joint variation is basically a combination of several direct variations. So if y varies directly as x and z, I kind of look at the product of x and z taking the place of a single letter. And so I can even say that y varies directly as x, z, w, and j. I can put 4 different variables there, but they'd all be multiplied together with that k. And you also might see these put together with inverse variations as well, which is kind of getting what the example 3 is doing. In example 3, you're told y varies jointly as x and z, and inversely as the square of w. So that first sentence that tells you how all the variables relate to one another is giving you your general formula. So let's write out a general formula right now. It says y varies jointly. So when I get that y varies part, that means that y is going to equal some constant. Now it's jointly, so I'm going to have a variable or two being multiplied to this k as x and z. So x times z, and inversely as the square of w. So with respect to that k up here, it's going to be inversely for the square of w. There's my general formula. That's how these variables relate to one another with the k value and with y. So in step 1, I need to find k. Knowing that, I know I have to be given an x, a y, a z, and a w in order to figure out what k is. And it just so happens I'm given an x, a y, a z, and a w. I'm told, when I get to step 2, y equals 4 when x equals 9, z equals 2, and w equals 3. So when I'm at this stage here, I can say, okay, well, according to this, I'm going to have 4 equals k times 9 times 2 over 3 squared. And it would be a good idea for me to simplify that right-hand side a bit. It can actually save me on some work. So right now I have 9 times 2 times k is 18k. 3 squared is 9. So this ends up becoming 2k. So I know that 2k equals 4. Dividing both sides by 2, I get that k would equal 2. Me knowing that constant of variation now means that I now have a complete formula for these variables and this constant. So now I could say that, well, instead of this, I'm going to have y equals 2xz over w squared. And the very last part is when it says, okay, we want to find y. So y is going to be my unknown here, which means that if I'm looking to find that, I have to have an x, a z, and a w. And I am. I'm given an x, a z, and a w. So if you keep track of what it is you have and what it is you need to find it, then you should have an idea of what you're able to look for and what you should be able to interpret. And if you don't have that information, you can say, well, I don't have that information. I can't do anything with it. You really shouldn't get to those situations where you're having information that's not known. They should be giving it to you, but it also helps you figure out what it is you do need to know. So for me to figure out what y is, I'm going to use these new values because, y was 4 when I had all these values. So if I use any of those values, I'm just going to get, well, y being 4 again. Now I want to see what happens with y when x is now 6, z is -2, and w is 2. So y is going to equal 2 times 6 times -2 over 2 squared. And I work this out, I'm going to have -24 over 4, which gives me a -6. And that's my answer for this. Since it doesn't really have this in any kind of worded context, I don't really have to answer with a sentence or have any units here because there's no units given. But it's the same general principle. I set up a formula based on the description. I need to find the constant of variation k. So I'm going to need to have the ability to fill in all the variable values for one specific instance. And then I'm going to be given another instance where I now am missing one of the values and given the other remaining ones, and I got to find what that value is. So the process is the same. It's just the formulas you end up having are going to be different each time, and will require, various steps of algebra depending on the circumstance. And that is the end of the notes I have for 2.6, and that brings us to the end of Chapter 2. So if you have any additional questions, please make sure to bring them up in class or come by my office hours. Until I see you in one of those or the next video, I'll see you around. Have a good day, everybody.